Dan, a co-committee member at IIT and I'll be your host for today's workshop. I'm sure you all have heard of NFTs and their exorbitant value, but how does the transaction between an NFT artist and a buyer occur? Well, there's a code present in the blockchain that verifies the ownership and handles the transferability. This is known as NFT smart contracts, a simple mechanism for implementing a sale agreement between an NFT owner and a buyer. To shed more light on this topic, we have our speaker, Mr. Ganesh Anantwar. He has been working with blockchain technology for more than 8 years, with experience in technical and management domain in financial services and supply, and currently a blockchain engineer at JP Morgan. We are grateful to have a speaker to help us discover this booming world of NFTs and how they actually work. Stay tuned for our upcoming flagship event, Blockit, a 24-hour hackathon which shall be conducted by our chapter IIT from 9 July to 10 July that will make you experience the magical world of blockchain technology. Let's start with a workshop. The platform is all yours, sir.
Hey guys, thanks Medansh. First, I would like to thank VIT and the organizing committee for giving me this opportunity to share whatever I know with the upcoming engineers. Uh, it's been a long time. I'll take a couple of minutes to introduce myself. So I passed out engineering just like you guys around in 2011. So it's been more than 10 years now. After that, I did my stint at IT. I completed my MBA, and then I worked at 4 years in JP Morgan again, but in the financial sector, not in technology. And then I founded my own startup for 2 years, where we were developing blockchain applications for supply chain domain. But due to COVID, the startup didn't work out. So I came back to JP Morgan, and now I'm an engineer in JP Morgan's blockchain division called Onyx. So we majorly work on financial applications. Uh, all right. Now, the way I want to take this workshop is that there's one way I can just like start sharing my screen and writing code. Okay, but that's not gonna mean anything, because if we don't understand what we are doing, then it becomes a problem. So generally what happens is, when I take workshops like these, I take the audience through the journey of Bitcoin, how what is Bitcoin and how it works, and slowly we arrive at Ethereum by understanding how Ethereum is different than Bitcoin. But I don't think we have that much time. So what I'm going to do instead is try to strike a balance by just giving, we will take like 20-25 minutes to understand the theoretical background on Ethereum. And we will have a small Q&A after that to solve any questions. And I think then we will still have 1 hour, 15 minutes or 1 hour, 10 minutes to do the hands-on. Okay. uh, you can follow me along, all the audiences, you can follow me along in a code along way if you are on your computers, or you can just watch this later and try to absorb everything and try things out later on as well. It's up to you. Okay. All right. I hope that's okay with everybody. So let's start with, okay. So I'm not sure how much you guys are familiar with blockchain or Ethereum or any of that. I'm gonna assume you have had some idea about this, because everyone is hearing about Bitcoin, Ethereum. Like many of you must have been putting some money in it. I hope not, because the market is down right now. But it's not only about the financial assets and the investments and cryptocurrencies as an asset class, like bonds or stock or gold or mutual funds like that. It's also about the underlying technology and how it works, right? And as engineers, I think it is very important for us to get acquainted with this technology. Now, blockchain is an emerging technology, what is called an emerging technology, along with cloud, AIML, IoT, AR, VR, right? These are the new technologies that have been coming up in last 1 decade, and they're trying to solve some real industry problems. Like you will have critics and supporters or proponents of all the technologies that you will find. I'm a proponent of blockchain technology. I believe it can bring in changes in the way we solve problems in the industry, right? But again, we are not here for applications of blockchain. We are here from a purely engineering perspective. So let's dive right into what is Ethereum. Once this theoretical session is done, I'm going to reserve like 10 minutes, 10 to 15 minutes for Q&A, and then we will move on to hands-on. All right. Okay, so what is Ethereum? I'll try to keep this as short and as playful as possible. Okay, so we are going to do Ethereum is a decentralized public programmable blockchain. Decentralized public programmable blockchain used to build something called decentralized apps using smart contracts. Now, that's a very heavy definition. If I was you and I was just in college, I would just ignore this, right? So, what does that mean? It's just a bunch of jargon, right? So, what I'm going to do is I'm going to demystify each of these words going forward so that we completely understand what it is. At this moment, I would like to tell you from a very layman's perspective, Ethereum is like Android. Okay. So just like on Android, you can build your apps, right? So you can use React Native or Flutter or like Android Studio, and you can build your own apps and you can install them on your phone, or you can put them up to Google Play and anybody can download those apps and use them. But in order to do that, you don't need to understand how Android works. You don't need to go into AOSP details, right? So similarly, in order to use Ethereum, you don't need to understand at the protocol level how Ethereum works. It's good to have some understanding about some very basic concepts, but in order to create apps on top of Ethereum, you don't need to have protocol level understanding. Okay. So this is what Ethereum is. You can basically create apps on top of Ethereum that do something. Okay, so and these apps are called decentralized application or dApps instead of apps, and they're powered by something called smart contracts. Okay, so this is the very bird's eye level overview of what is Ethereum. Now let's dive in. That was too much, right? What does it mean by being decentralized? Okay, so there are two concepts in computer science. A system is either distributed and it could be decentralized. Okay, so decentralized is a subset of distributed system. For a system to be decentralized, it has to be distributed. Now, what is a distributed system? Very simple terms, distributed system is a system which has a network of multiple computers. It could be anything. It doesn't have to be only blockchain. I'll get to examples. But if you have multiple computers connected through a network, mostly TCP/IP, which is internet, and they communicate with each other through some protocol, then this is a distributed system. As soon as we say a system is decentralized, then we are talking about control. So who is controlling that system? So let's say even if we have hundreds of nodes, but it is being controlled by a single authority, then that system is not really decentralized. It is centralized. Okay, so what are some of the examples? So let's take the example of centralized and non-distributed. Okay. So it's a very simple example. These are a traditional software. So you have MS Excel, which is only on your computer. You have Photoshop, which is only on your computer, and it is completely owned by you, the owner of the operating system, right? There's no one else involved here. So this is centralized and non-distributed, right? Now let's move on to centralized and distributed. I'm pretty sure everyone has used Google Drive or Gmail. But if you know, in the background, Google has huge number of servers, okay, which are driving this very complicated application. Google Drive seems very simple, but it's not that a simple application. Actually, Google Drive is distributed. It is being powered by a network of computers in the backend. So it is distributed, but it is still owned by Google, and Google has absolute authority over all the data that we put in. Now, it's not in their business interest to do anything with our data, and they claim that it is encrypted. Might be, might not be, I'm not sure. but it is an example of a centralized and distributed system. Now, what is the example of a distributed system which is also decentralized? Means it is on multiple computers, but it is not controlled by anybody. The best example, and we used to use this a lot in college, is torrent. So if you have worked with BitTorrent or MuTorrent, right? So these applications allow you to share files. Generally, people download movies or books or TV series, right? So these are streamed from multiple computers, peer to peer. So torrent was the first example of this kind of system, and blockchain just took it one level up. It is completely different than torrent, but blockchain is also an example of a system which is distributed and decentralized. Hence, Ethereum is also an example of a system which is distributed and decentralized. Okay, so I hope that demystifies decentralized keyword. If you move on, now what is a blockchain? I think before blockchain should, okay, let's come to blockchain. Blockchain is we just saw it's a distributed and a decentralized system. It's a network of computers. Okay. Now, this network, for all the computers in this network, they are called nodes. So we are going to say nodes from now on. So each node, it looks at the network and it sees exactly the same data structures. Doesn't matter what, like at any given instant of point t, time t, it's always going to look at the same data, all of the nodes. It is not possible to change the data or the global state of this blockchain network. So the data in the blockchain, we call it as the global state. So it is not possible to change it by a minority of nodes. So let's say there's a blockchain network which has 100 nodes. So it is not possible for only 49 nodes to just change whatever is in the blockchain. Now, there are some caveats to that according to consensus algorithm and that, but again, I am not going to protocol level. This is more of a application level engineering class. Okay. Now, what does this network do? This network allows you value transfer from one account to another. Now, what does that mean? Let's take a very quick example. I have an SBI account, you have an SBI account. I have 1,000 rupees, you have 1,000 rupees. Now, I send you 100 rupees via Google Pay or any other UPI app. What happens? My balance becomes 900 and your balance becomes 1100. But where is this data stored? Where is the database or a table that is saying that my balance is 900 and your balance is 1100? Where is that data getting changed? Right? It is SBI's service, correct? They have some complicated system with their own database, their own backend, Java, Python, JavaScript, doesn't matter, right? So the point is that entire system, that record, that ledger, it's a financial term, ledger, it is owned by SBI. Even if it is digital, it is in a single place. What did we just learn? That means it is centralized. Okay, so SBI acts as the final authority on what is happening with the balances. Okay, now uh, imagine that we don't want SBI. We want to remove SBI. It's just you and me. And we want to create a system where you have a copy of Ledger. I have a copy of Ledger. So everyone in the system has a sheet, you can say, which tells what is each person's balance is. Like A's balance is this, B's balance is this, right? And then if we can enable, now I need to transfer 100 rupees from my account to your account. So I'm going to broadcast a transaction saying I'm transferring 100 to your account. Everybody will see that transaction and everybody has to accept that, either accept or reject that transaction and make the changes in the balances according to that. Okay. So this is a peer-to-peer electronic cash system. And this is the name of the original Bitcoin paper written in Satoshi Nakamoto in 2008. So this is what we say when we say value transfer. Underlying, it is still data, but it is enabling something very unique. It is enabling us to transfer money or value from one point to another without relying on any central authority. And this was a very, very difficult problem to solve. To be honest, there were two very specific computer science problems that had to be solved to for this Bitcoin paper to make a success. They are called Byzantine fault tolerance and double spending. Both of those problems were solved. in the Bitcoin white paper, in what I like to call like 8 pages of or 9 pages of intellectual heroism. But anyways, those problems were solved. I'm not going to go into details of how they are solved, but this is what a blockchain enables. Okay, what happens in a blockchain network is each user has an account. Okay, this account is generated using cryptography. We will come to that. And users keep sending transactions to the blockchain using their account. So they create a transaction, they sign their transaction, and they broadcast it to the network. All right. Now, what happens is every blockchain has a heartbeat. Okay, that heartbeat is called a block time. So, for example, Bitcoin's block time is 10 minutes. Ethereum's block time is around 13 seconds. There are certain blockchains which are way faster, like Polygon, which has like 2 seconds block time. What happens is in Ethereum, let's take an example. Every 13 seconds, now everyone is broadcasting transactions. So all the nodes in the network, they are collecting all those transactions into something called a memory pool, right? Now there are certain special nodes which are called miners. What these miners do is every 13 seconds they collect all the transactions, they order them, right? And what they do is they take the hash of the previous block. Okay, they collect all these transactions into a block. Okay, just a data structure, nothing else. They take the hash. I hope everyone knows what a hash is. They take the hash of the previous block, they add it into that, right? Now they have a new block that they have to create. Now all these miners, they get into a race. What is the race? They have to find a special number. Okay, how do they have to find a special number? Let's say there is a rule that that number should start with n number of zeros, like 15 zeros. Okay, so they have to get 3 pieces of data. They have to collect all the transactions, they have to get the hash of the previous block, and now they have to choose a number in such a way that the hash of the new block is less than hash of the new block has n number of zeros to start with. Okay, and there's only one way of doing it. So you first choose that special number as 1, and then you hash the block. You see if you have a right answer. There is only way to do that is trial and error. The reason for that is hash is a one-way function. You cannot go back from hash to the original data, right? So there's no way to cheat that. So you continuously do trial and error, trial and error. You put 1 in the block, you hash it, you see if it is valid. You put 2, you see if it is valid. You put 3, you put it, see if it is valid. Hey guys, apologies for that. 1 second. Hey, sorry for that. Okay, so you keep hashing this block until you arrive at the right answer. As soon as you find a valid nonce or a valid special number, the miner broadcasts it to the entire community, and whoever finds it first, they get the extra coins. I'm really sorry about this. Hey guys, I really apologize for that. I know this is being streamed. Okay. Uh, all right. So as soon as a miner arrives at a valid block, everyone they broadcast it to the entire blockchain network, and that block gets appended to the rest of the blockchain. Okay, a miner that finds the solution first, they get some reward as coins in the native cryptocurrency. So Bitcoin network's native cryptocurrency is Bitcoin, Ethereum's native cryptocurrency is Ether. So basically, we are incentivizing the miners. We are saying to the miners, if you keep doing this, if you keep burning electricity and find the right block for us, we will give you some coins. So it is like a public service. But the thing to understand here is that there's not a single authority that has control over the entire network. If we have sufficiently large number of nodes, then no single authority or no single entity is controlling the network. Now, why is this important? If we look at the diagram here, this is how a blockchain looks like. So we have a block, we have that block's hash, okay? Then the next block will contain the hash of the previous block plus the transactions, plus now we will try to find our block's hash so that we have that special number, etc. Right? So this creates a chain of blocks. Now let's say you are an attacker and you want to change this middle block, right? If you want to change this middle block, as soon as you change this, your block's hash will be changed. That means the next block's previous hash is going to be changed, right? That means the next block's hash is also going to be changed. So this entire chain breaks down if you change any data between any transactions inside a block, right? So if an attacker wants to change some data and fudge some data, they have to change the blocks of all subsequent blocks in the blockchain, which is computationally infeasible. That's a special word that we use in computer science. It's not impossible theoretically, but it is infeasible. For example, it's going to take them hundreds of years to do that. Why? Because miners have already put in a lot of efforts finding this correct block. So you have to be more powerful than the entire computational effort put into the blockchain. So now this consensus algorithm is called proof of work, but again, I'm not going to go into details of that. Okay. Next keyword or jargon is public. What does it mean when we say Ethereum is public? So Ethereum is public because anyone can interact with the Ethereum network if you have a wallet account. So you need a wallet software and you need a specially generated account exactly according to Ethereum's algorithm. And you can do it outside the blockchain also. And you can interact with the network. You can create your own transactions, you can sign them, you can send it to the network. Anyone can join Ethereum by running their own node. So if you have enough hard disks or enough powerful computer, then you can become a miner yourself. You can join the network. You can also join the network without becoming a miner. In that case, you will be only reading and writing the transactions. You would not be doing the process of mining, but that is also possible. All the data, all blockchain data, all the transactions that we saw, this is all public. And all of this can be seen using something called a blockchain explorer. And all the programs also on Ethereum, all of it is publicly available for anyone to see. And that's why we have like total transparency. We cannot look into SBI's system, right? That would not be right. Like, SBI will never allow that. But in blockchain, everybody can see everything. Still, nobody can change it or nobody can attack it in a malicious way. Okay, now let's come back to the most important point. This is the difference between Bitcoin and Ethereum. Now, what we need to understand here is that Bitcoin was the first blockchain, okay, in existence. But Bitcoin can do only one thing. It can send Bitcoins or coins from account A to account B. That's all Bitcoin can do. Bitcoin cannot do anything else. Okay, that is the thing that you need to understand. So once Bitcoin became successful, a lot of other people started to build their own blockchain. So they started to build different networks. Okay. For example, I'll give an example of Ripple. Okay. So what Ripple has a cryptocurrency called XRP. It's its own network. And you must have heard about Dogecoin, right? Which is a meme coin, which has no use, but still it's like big for some reason. Ripple has a use that if you want to send cross currency transfer, so let's say you want to send some reals to some of your relatives in Dubai, or you want to send USD to some of your relatives in the US, right? So how do you convert INR to USD? Now, if you go to the traditional financial infrastructure, there is like a whole correspondent bank, Nostro, very complicated setup that you have to go through, and it takes you days. Like it's called T+2 or T+3 or T+1, sometimes T+5. So if you send the money today, it will arrive in US 3 days later, something like that. So what Ripple is trying to do is, Ripple is trying to replace this entire traditional financial infrastructure in such a way that you can directly send INR to USD within minutes. That's what Ripple is trying to do. So my point here is that a lot of other blockchain projects came up after Bitcoin, but they were also trying to do one very specific thing. Bitcoin just sends coins from A to B, and these guys were trying to do something different, but that was again a very specific thing, right? So basically, they only allowed computations which were more complex than Bitcoin, but they were already predefined and hard coded. It's not like you could do anything. So there was a person named Vitalik Buterin who was involved in some of these projects, and he posed a simple question. His question was very simple. So instead of having a lot of application specific blockchains, why can't we have a single public blockchain, right? Instead of creating 100 blockchains, why can't we have a single blockchain network, and we can write programs on top of it, so we can tell the blockchain to do what we want to do, right? So it's not rigid or hard coded. We can write a program or an app on top of this blockchain. That app will do whatever we want to do. Okay, so what we can do, that is how Ethereum came into existence. So in 2015, Ethereum, Vitalik Buterin with some of his co-founders, there's a great story around that as well. You may want to read the book called Cryptopians if you're interested in that kind of stuff. uh, what we can do basically on Ethereum, which came into existence in 2015, right, which is still a new technology, it's only 7 years, is that you can define a program of any complexity on Ethereum, effectively creating automated agents of computation that can do any value transfer logic, right? So for example, you can lock money into it and borrow money out of it. You can create some token that represents, let's say, real estate, right? Or you can create tokens that represent digital art, which is what we are going to do today, right? So these programs that we write on top of Ethereum network, these programs are called a smart contract. This is what you need to understand. The programs that we write and deploy on the Ethereum network, these are called smart contracts. Okay. So what are smart contracts? Smart contracts are programs. They're just like your Java programs, other programs, with some quirks. Okay. First thing is, each of these programs, each of these smart contracts has a state, and they have functions. Guys, 1 second. And they have functions that can act on this state. So for example, if you write a simple storage contract, you have a variable called storage or value, and then you have a function like set storage and get storage, right? The magic about this is that this program will be deployed on all the thousands of nodes in the Ethereum network. Let's say there are 40,000 nodes in the Ethereum network. It will be deployed on all 40,000. And in order to interact with this, anybody in the world can send a transaction. What is a transaction in this case? In this case, for Bitcoin, the transaction is sending coin from A to B. For Ethereum, a transaction is you're invoking a function of a smart contract with specific input parameters, right? So you say, I want to call set storage with X value, right? Set storage with 123 value. So you wrap this into a transaction, you sign it with your account, and then you send it across to the Ethereum network. And that will be, like I said, collected into the mempool. And after 13 seconds, if you send, now there are certain conditions if it gets included in the blockchain or not, but let's assume it gets. So once it gets included in the blockchain, that transaction will change the value from whatever it was to 1 to 3. Okay. And this is how it works. All right. So what we need to understand is, this is not like a C program or a Java program or a Python program. This program is running on all the nodes. It has to be absolutely deterministic. That means that all 40,000 nodes should arrive at the same answer of whatever computation you are doing inside your function. Okay. So these has to be absolutely deterministic. So for this reason, we cannot use traditional programming languages. So we cannot just use C or Java or Python here, because they have certain things called random number generators. They have certain other things also which stop us from creating deterministic results. That is why Vitalik and Ethereum team, they created a new language for writing smart contracts. This language is very, very simple, right? Like you can learn it in couple of days, I would say, right? But it's not about the simplicity of it. It's about that it's going to be executed in a very resource constrained environment. You cannot go crazy on it. Okay, you cannot write a very complicated program. The program has to be simple, and the program has to be very clear, and the program has to be secure, because the entire world is going to have access on it. So if you're locking some money into that program, then you will have to be absolutely secure with that. Okay, so this is what a smart contract is. One quick thing: a smart contract is not smart in the AI sense of things. So we have like smart cities and smart cameras and smart phones, right? It's not smart in that sense. It's a misnomer. And it's not a contract in the legal sense. When we say smart contract, it's not a contract. Okay, so if anybody tells you that smart contract is a legal structure, it is not. It is a computational structure. It is a program. Okay, all right. Next question is, every time you send a transaction to Ethereum blockchain, you have to send some ether with it. Why do we have to do that? Now imagine we did not have this ether requirement. What would do is, anybody could send hundreds of thousands of transactions continuously to blockchain for free, and they will flood the network, and they will consume the resources of all the nodes. And these nodes are run by thousands of people, different people who are not related to each other. So that would be unfair to them, right? There's a second reason. It's called Turing's halting problem. In Alan Turing, which is father of computer science, and you should watch Imitation Game if you haven't already, is that there is no way, it is mathematically impossible to understand, mathematically impossible to know if and when a computer algorithm will stop executing. Okay, and when that happens, we say that program is Turing complete. One example of having Turing complete programs is like infinite loops, or like for loops or while loops that we use. Okay, now let's say we have someone, we don't have this ether requirement. So what will someone do is, they will write a smart contract which has an infinite loop inside it. Okay, and then they will send a transaction to it, and that program will continue running, and it will consume all of the resources, and we don't want that. So in order to solve this Turing completeness and Turing's halting problem, what Vitalik came up with is ether. Okay, so what ether is, every time you either deploy a contract or you send a transaction to the contract, you have to send some money with it, which is the native cryptocurrency of the Ethereum network. Okay, where is ether created? It is created by miners when they power the network. You need to give them something, right? And let's say you send some ether with your transaction. Your transaction is so complicated that you run out of ether before it is completed. Then your transaction will be reverted, and you will not get your ether back. Okay, that might sound harsh, but you have to have that because this is a public network. Okay, all right. So all right. There are two types of accounts in Ethereum. This is very important. There's an external account. I'll show you all of this. There's an external account, okay, which is your user account. Okay. A user account has a private key, okay, and a public key derived from the private key. Which algorithm we use for this? We use an algorithm called elliptic curve cryptography. I don't know if you guys have a cryptography class. We used to have a cryptography class in final year, and we used to study this book called William Stallings back in that time. But I have taken a lot of workshops, and some of the colleges don't have that class. Everybody's talking about AIML nowadays, but I think cryptography is absolutely essential. So every final year course should have, like, at least it should be an elective. Okay, so we had RSA, and now we have elliptic curve cryptography, which is far more efficient and secure. So using ECC, we generate a random private key, and then we generate a public key out of that private key. And this public key is used to derive an address. Okay, this address is your account number. So like you have an account number in the bank. So this address is your account number on Ethereum chain, right? And you can sign transactions using your private key and send them to the Ethereum network. Then we have contract accounts. Now, contract accounts are also accounts, but they don't have any private key. That means they're not controlled by any one person. They just have an address, okay, which is derived from their code, but let's not get into that. They have some code inside them, which we will write using a smart contract language called Solidity. I just explained to you why we need a special language for writing smart contracts. And they have their own storage, right? So we'll get into this. But this is the most important thing to understand. Now, how does external account work? each user has a private key and associate public key. We've gone through that. These keys are used to sign transactions. So I construct a transaction, I sign it, and I send it to Ethereum blockchain. You don't have to do this manually. You have something called a wallet software, which is available to you, and you can just interact with the blockchain using a wallet software. So the thing to understand here is that in blockchain, there is no username password. I will repeat, in blockchain, there is no username password. There's just a private key and your address. So your address is like your username and private key is like your password, but your private key is not given to any platform. Okay, it is with you and you should keep it with you. If you lose your private key, you lose your account. So your key is your account. There's a thing, people say that your keys, not your coins, right? So platforms like WazirX and all, they don't give you your own private keys. So when I buy Bitcoin or you buy Bitcoin, all that Bitcoin goes into WazirX's account. So we don't have control over that. Okay, so that is a very complicated thing to understand, a very important thing. Whatever blockchain app you are interacting with, your key should never leave your wallet. If that is being satisfied, then it's a true DApp, it's a true decentralized application. Otherwise it's just centralized. Okay, it doesn't matter what people are advertising. All right, second thing is to understand is we only sign the transactions and send them across. Okay, so digital signatures are different than physical signatures. So when we sign something, it is important. The signature also depends on the content of the transaction. Let's say I change the content of the transaction, the signature also changes. Again, you can Google about this. The point I'm trying to get at is that in blockchain, there is no encryption. There's only signatures. No data is encrypted. All data is available on internet. I'll show you how a blockchain looks like, and you can get all the data, even private variables inside a smart contract. You can see all of it. So if anybody tells you that blockchain uses encryption, they really don't understand it. Okay, blockchain does not use encryption. It uses cryptography for security, and it uses cryptography for digital signatures. There's no encryption in blockchain. Okay, all right. Now it's very difficult. Let's say I want to maintain 10 accounts for each app, or I want to maintain like my like personal account and main account, and I just want to keep less coins in my personal account. It becomes very difficult to manage these tens or hundreds of accounts. So people have come up with like this brilliant scheme called hierarchical deterministic wallets, where what happens is you put in a 12-word seed phrase. Okay, so these are 12 words that you have to remember, and then you can generate literally infinite accounts, 2 raised to 256 minus 1 to be precise. You can generate, which is a humongous number. It's more than like total number of atoms in the universe. But anyways, you can generate any number of accounts from this 12-word key phrase, and it will generate those in exactly the same sequence. So let's say even if you lose your wallet software, but you still have your keys and they're secure, you can still generate exactly the same account, same private key, same address. So these wallets can act as keychains. Okay, so users only need to keep their seed phrase safe and they're good. So should we play with a wallet, or should we take? So I'm basically done with the theoretical. Yeah, I'm done with theoretical things. So Midanshu, right? Should we open for questions before we go on and do hands-on?
So we'll have our questions at the end. Right now, we can continue with the session.
Okay, all right. Okay. In order to use Metamask, so Metamask is the world's most famous Ethereum wallet or blockchain wallet. It's the most popular, at least. It is built by a company called Consensus. Now, how Metamask works is that what I'm going to do, I'm going to uninstall my current Metamask. I will show you how to install it. Metamask is a browser extension. That means it's attached to your browser, which is Chrome or Firefox or whatever else you're using. Okay. So what I'm going to say is you can just go to Google and say install Metamask. Okay. You will go here. You will say download for Chrome, add to Chrome, add extension. It will take, yeah, it will take a couple of minutes. Once you Once it's installed, it will say get started. Yeah, you can say get started. Now you can load an existing recovery phrase, the 12 words that you have, or you can set up new ones. Okay, so I'm going to say create a wallet. I agree. You will need a password, but this password is just to protect the wallet software. Okay, it doesn't serve any other purpose at the blockchain level. Okay, all right. Just gonna put some password in here. Create. You can just say next, right? And I can say reveal. So you can see it gave me these 12 words. Okay. I have to write these words down somewhere and I should never lose it. Okay. For now, I'm just going to take a screenshot. Okay. All right. I'm going to say next. Now it's going to ask you to confirm these words. Otherwise, it will not allow. So it wants to ensure that you have noted it down. So I'm just going to do this. I know I'm taking some time, but this is very, very important. So you should know how to interact with the blockchain. Bottom, smile, manage, erupt, pen, glove, fancy, confirm, all done. Okay. So you can see here that you have your uh, Ethereum. So it is connected to the Ethereum blockchain, and it is saying I have 0 ETH. Of course, I have 0 ETH, and this is my account. Okay. If I want to see it, I can just copy it in Notepad. So this is how an Ethereum address looks, or an Ethereum account looks. And the private key stored inside Metamask. Metamask is managing everything for us. Okay. We don't want to communicate with the actual Ethereum blockchain because it's going to cost us Ether. Okay. So it costs us actual money. So what we can do is we can use a testnet. Testnet is just like Ethereum, but it has like you don't need to spend actual money for it. So you can just test it out. Okay. What you can do is you can go to advanced and you can enable test networks. So show test networks. Once you do this, you see that you will have a lot more options here. So these are all Ethereum testnets. So you have Ropsten, Kovan, Ringb, Goerli, right? So you will need test Ether in order to interact with these chains. Okay. There's another way. You can run a local blockchain also, just like we run a local host Node or local host PHP or local host Java, local host Python. We can run a local host Ethereum also. The software used to do that is called Ganache. Okay, not Ganesh, Ganache. So it's spelled Ganache. Okay. According to whatever your operating system is, you can just Google about Ganache and install it. Okay. I have a Ubuntu system, so I have already installed Ganache. All I have to say is just press Ganache, and you can see it started a local blockchain. Now this blockchain has only one node, which is my computer, and it is running on port 8545. You can see localhost 127.0.0.1.8545. Now what I can do is I can connect to this chain. Okay. If I just select localhost, so you can see I am connected to this blockchain. What is my first account? So what Ganache does is it gives you like 10 accounts to test your stuff out. Okay, but you have to import those accounts in MetaMask. I'm not going to go into that. Okay, but this is how you can have a test network which is running, or you can have a local network. Test networks are actual networks. Okay, they are out there, people are running them. A local network is just what you have on your laptop for testing smart contracts. Okay, I think we have covered testnets, Ganache. Okay, we'll come to writing smart contracts. All right. Okay, how do we go about writing smart contracts? In order to, now this is a beginner level session, so I'm not going to go into details. I generally use VS Code. Okay. So I'm going to show you how what like a complicated smart contract looks like. 1 second. So I have this project on my GitHub where I'm building a math library for Solidity smart contracts. It's called Argon Math. So this is how a actual production level smart contract looks like. So you have a bunch of comments, you have all this stuff, and you need VS Code to do this complicated coding. Okay, this is some like very mathematical stuff that I'm doing, but anyways, this is how a smart contract looks. You can see that it has a bunch of functions and all that. Okay, so I'm not going to use VS Code. For beginner level, you can use something called Remix, which is an amazing tool. So you go to remix.ethereum.org. Okay, you click on Solidity. Okay, now this Remix is an IDE. It's just like VS Code or IntelliJ or Eclipse or whatever you use, right? But it's in the browser. Okay, because we need to interact with MetaMask, that's why it's in the browser. So you have this pane, which is the console. You can clear the console out. I hope everybody can see and the font is not too small. Okay, here you have a bunch of tabs. So this is your files tab. Okay, what you can do is you can go here and create a new workspace. So I'm just gonna say call this NFT workshop. Template, I'm just gonna take blank. I don't want any contracts here. Okay, all right. Then what I'm going to do is I'm going to create a folder called contracts. So you always have to create a contracts folder where you can put your contracts. Okay, and let's just start with simple storage to get some idea. So we have simple storage.sol. Now every Solidity has an extension SOL. Okay, just like JavaScript files has .js or Python has .py. So this is .sol. Okay, the first thing that you have to do, because all smart contracts are public, you have to put in your license at the top. Okay, so you have to say this spdx license identifier. I'm just gonna say MIT means it's free. Okay, in fact, what I'm gonna do is I'm gonna copy some stuff over to save time from my math contract. Okay, so this is the first line that you have to do. Okay, so this is spdx license identifier MIT. Then you have to give the Solidity version using this pragma statement. So pragma Solidity, you can either do equal to 0.8.8 or you can do like greater than like this. I like to do equal to because I want this exactly the same version. Okay, the reason to do that is that Solidity is I'm going to do this 8.7. Solidity is a fast changing language. So there's a lot of new features coming in. So you should be sure about which version you are using. Should do not use a version less than 8.3 currently. So 8.7 is safe to use. Right? How do we start a contract? We just say contract simple storage, right? And then curly brackets. Okay. Now there are two parts into this. We have our state variables in the contract, which is the data in the contract, and then we have functions that act on that data, right? So we can say now you can read about the data types in Solidity. Uint means unsigned integer, an integer which starts from 0. So I'm just gonna say uint 256 private value. Okay, uint 256 private value. This is my variable. All right. Now I want to write two functions for this. I want to write a setter function and a getter function. So I'm just gonna say function set value. I'm gonna take uint 256 x, right? I'm gonna say now we have to specify functions visibility. That means that if we put function as public, then it is available to external users also, and it's available to other contracts also. If we say external, then it's only available to external users. If we say it's internal, then it means that the function is available to this contract and any other contract that will inherit it. And if it is private, then it means it's only available inside this contract. Now you can Google all of this. The best resource to learn this into detail is is Patrick Collins' Solidity course, 32-hour Solidity course. You can just go Patrick Collins free code camp Solidity course. So it's on YouTube. Yeah. So you see this 16-hour course is for using Solidity with Python, and this 32-hour course is for using Solidity with JavaScript. So whichever language you're comfortable with, you can use. You can go through these courses, and this is like getting a blockchain certification. Trust me, it's amazing. So even while I have been working with blockchain for more than 4 years now, I when I went through this course, I learned so many things. So please go through this. I'm not going to go into details because we are going to focus on NFTs. Okay, so I'm just going to show you this simple storage contract. So set value, I'm just going to say public, right? Return, it doesn't return anything. So set value is only going to set value. It's not going to return anything, right? So we are just going to say, yeah.
So can you zoom in the code? It's not actually
Sorry,
visible to the users. So can you zoom in the code? It's not actually visible to the viewers.
you want me to zoom this in?
Yes, sir. Thank you, sir.
Should I zoom it in more?
No, sir, it's fine now.
Fine. Okay, let me zoom once more. Okay. So function set value public, and I'm just going to say value is equal to X. So whatever I'm passing, I'm setting that equal to X. Then we want to create a getter. So get value, right? Get value doesn't take any input. It's public, and it's going to read the state of the contract, right? So we have to say it's view, and then it is returning a value, returns UN 256, right? Now what we are going to say is return value. That's it. We're done with our first contract. Now, did you just see as soon as I pressed Control S, it automatically. Hey, just 1 second. Yeah. So as soon as I press Control S on this contract, it automatically compiles it. Okay. So when it compiles it, it generates this artifacts folder. Okay. And inside that you have simple storage.json. So this is your compilation output. So what Remix is doing is it is compiling your contract into something called bytecode. Okay, it's a EVM bytecode. So just like we have a JVM Java virtual machine, we have a Ethereum virtual machine, which is translating this into EVM opcodes. Okay, which is a low level language. Solidity is a high level language, so that the Ethereum software or Ethereum nodes can execute it. But we don't need to worry about that. We only need to understand that our program gets compiled into, our smart contract gets compiled into EVM bytecode, and then that bytecode gets deployed. Okay. Now, where do we deploy it? Where do we deploy this contract to test it out? Now, you can deploy it on actual Ethereum network, but that will just cost you money, right? You can deploy it on Ganache, like I showed you. Okay. Or you can deploy it on some testnet. Okay. Through MetaMask, you can interact with the testnet. I'm not going to go into details. I'm just going to show you how to deploy it on Ganache. Okay. So just start Ganache. Now you have your blockchain running. Let me zoom this in as well. Okay. So Ganache gave me like 10 test accounts. You can see first account starts with 4F and it has like 1000 dummy ETH for me to work with. Now I go to the deployment tab. Okay. If I don't write something correctly, then the compilation is going to fail. So you see, if I miss the semicolon, it's going to say that parse error, I'm expecting a semicolon. So yeah, all right. I go here. Now I have to connect to Ganache. I have to select which environment I'm deploying to. So I'm just going to say go here and I'm going to say Ganache provider. So it is automatically going to load your localhost 8545. Just say okay. And see what happens when you say okay. It loads the 10 dummy accounts for you automatically. into Remix. And now you can go ahead and play around with this. Okay. So you select the contract that you want to deploy and you just click on deploy. Okay. So you see that contract has been deployed. Okay. This is the contract's address. All right. So if I copy this, so you can see this is the contract address, and we just saw that contract address does not have a private key. Nobody controls the contract. It's just there. The simple storage contract is living on our Ganache blockchain now, and nobody has control of it, not even me. Okay. All right. Now you can see as soon when we expand this simple storage contract, we have two functions, set value and get value. Now set value is red or amber because it is a state changing function, right? So it is changing the state of the contract. We're changing something. So we can think of this as a write or transaction, and get value is only a read transaction. We are only reading the value from it. Okay. So if I just click on get value, you see it gives output 0. So I haven't set it to anything. So it automatically sets to 0. Okay. Now if I want to set it, let's say 1, 2, 3, right? I say, just 1 second. I want to show you the console output as well. This is the console. When we deployed the contract, it created a deployment transaction like this. Okay, but let's forget about that. When I click set value, see, so our transaction just went through, right? And you can see 2 transaction mined and execution succeeded. You can go back to Ganache, and if you check Ganache logs, you will see that your transaction is just, yeah, you can see your transaction is just gone in, and you have some gas usage along with it. Okay, gas is not ether. We will come to that. If we have time, we will get into those details. Okay, so we can see that this much gas has been spent for this transaction. Now if we do get value, you can see it's been changed to 1, 2, 3, right? For get, it does not cost any gas for read only functions. It only costs gas for write functions. Okay, all right. So now the problem is not problem. Now let's get back to the main point. Okay, what are tokens? What are tokens? We just saw that Bitcoin was an entire blockchain which could do only one thing, which is sending coins from one account to another. Now here comes the Ethereum magic, right? On Ethereum, you can write a 10-line smart contract that can mimic Bitcoin, that can create a Bitcoin-like coin for you in 10 lines of code. I'm not kidding about this. This is actually true, and that is why like people are creating hundreds and thousands of coins. People are doing scams also by creating new coins. It is literally 10 lines of programs to create a Bitcoin-like coin, okay, on Ethereum. In order to do that, we have to use a standard. So now while writing smart contracts, there are certain standards, there are certain proper best practices when you write smart contracts, but that's a whole session altogether, learning how to do smart contracts. But when you do that, there are certain standards which are defined by industry experts. So in order to create a Bitcoin like coin or a Dogecoin like coin on Ethereum, you have to follow a standard called ERC20. Okay, so I'm just going to Google for ERC20. And if you go to Ethereum's official site, no, this is not the official site. Yeah. If you go to Ethereum improvement proposals, eips.ethereum.org, and you go to EIP20, you will see that it has a specific definition of what a ERC20 contract looks like. So it has a name, it has a symbol, it has decimals, it has total supply, and all of this stuff, right? So we have to follow this exact same thing. Now the problem is, why do we need to code this from scratch? Okay, so there's an amazing company called OpenZappelin, which has already coded all of these smart contracts for you. All you have to do is inherit that smart contract in your contract, and you're done. So, and all of these contracts are security audited also. So you don't need to like lift a finger to create an ERC20 kind of token. Okay. So what we are going to do is we are going to create another contract. So let's say let's say VIT coin, right? Let's say VIT coin dot sol, right? I'm going to just copy the license identifier as it is and solidity version. Again, I'm going to zoom this in. Right, I'm just going to say contract VIT coin. Okay. Now we want to inherit ERC20 contract from Open Zeppelin library. Okay, so we can just go to Open Zeppelin ERC20. You can already see I have so many search items on Open Zeppelin, but that's because the entire world uses it. Go to Open Zeppelin, make sure that you're on version 4. Don't use older versions, right? And you can see that you can simply import the base contract, ERC20 contract, right? So if I just copy this import, paste it, okay, and I have to inherit this. So I'm going to say VIT coin is ERC20 and it has a bunch of other stuff, okay. And if I just store this, it's going to give me an error. The error is because the ERC20 contract requires a constructor. That means it requires certain parameters just at the start, okay. I hope you guys know what the constructor is. So what I'm going to do is I'm going to say constructor. I'm not going to pass. Now this is our constructor. This is VIT coins constructor. We are not going to pass anything to it. And then we are going to have ERC20's constructor, right? ERC20's constructor, we are going to say, we need to pass the name of the coin and the symbol of the coin. Okay, 2 strings. So name of the coin, coin just for VIT. Okay. And then we call this VIT C, right? Let's call it VITC, whatever. Now we have this coin. As soon as we store, we see that the error has gone away. But where is the supply, right? Where do we have these coins to start with? Okay. So in order to do that, you can create complicated mint mechanisms. But what we will do is we will simply send the creator of this contract, like the owner of this, not owner, the whichever address deploys that contract, we are going to send it a bunch of VIT coins. Okay. So what we are going to do is we use the internal mint function. Okay. Mint to message.sender, which is any account that is sending this. And we are going to say, uh, 1 million coins, right? There's one more thing that you have to do. You have to now in Solidity or in smart contract standards, the decimal numbers are 18 decimals, okay, like 0.0000018 times. We don't want that, like that's too cumbersome for our understanding purposes. So we'll just set the decimals to 0. Okay. So so there is a decimals function already inside ERC20. Okay. So we want to override that function. Okay. So we are going to say internal override returns. Now you might be asking, where are you getting all this from? Why are you writing this code? So you can just go to the actual ERC20 contract and you can see that. I can show you. Wait, I don't want to make this too confusing. Not this project. So if I go into node modules, I'm a JavaScript developer. I do JavaScript, no Python. Okay. Open Zeppelin, you can see when you install npm install Open Zeppelin library, it gives you all the contract tokens, ERC20, and this is the ERC20 contract. This is Open Zeppelin's contract. This is what we are inheriting, right? So if you come here and you look at decimal function, let me just search it. Yeah, so you can see the decimals function here, function decimals, public view, virtual, override, returns, whatever, right? So I'm just going to copy this and I want to override this. That means I want to use my own, not Open Zeppelin's. So I'm going to say decimals are 0. Okay. We don't want any decimals. Done. We're done. That's it. We just created a VIT coin. Okay. We can go here. We already have Ganache connected. Okay. Just going to open the console, clear the console, or delete this contract. Now I have VIT coin. I'm going to say deploy. And as soon as I open it, you can see it has all the ERC20 functions that we need. Okay. Now, what did we do in our contract? We said that the address which is deploying, we are just going to give 1 million coins to that address. So what was the address? This was the address, right? All right. Now we can check the balance of any address. Okay. So I put this address and you can see that I have 1 million balance. I click on decimals, you see it's 0. I click on name, it is coin just for VIT. I click on symbol, it is VITC. I click on total supply, it is 1 million. Okay. Now I want to transfer coins from this account to another account. All right. So let's say this 10th account, right? If I take this 10th account and I check its balance, it's 0. This 10th account has nothing, right? So what I'm going to say is I want to send to the 10th account, right? I want to send 1, 2, 3, 4 coins to it. Okay. 1, 2, 3, 4 VIT coins to it. Now, if I transact this, this is going to fail. Why? It is saying that, so when some error occurs in your transaction, this is how you get your error. So it's saying transfer amount exceed balance. So it is saying that I'm trying to transfer 1, 2, 3, 4, but I don't have 1, 2, 3, 4 in my account. But which is weird, right? Because I had 1 million in my account. The reason is, where are you sending the transaction from? Which account are you sending from? You remember we switched the accounts to the 10th account. So we're sending it from the 10th account, not the first account. And it is the first account that has the balance. So always ensure from which account you want to send a transaction, always select the correct one from here. Otherwise you will get weird errors. And when I was starting out, I literally spent hours on these stupid mistakes, right? So this is a very important thing to remember, and it happens with everybody. Okay, just ensure that you have the correct account that you're sending it from. So I'm sending from the first account, sending the transaction from first account, which has 1 million coins. I'm sending to the 10th account with 1, 2, 3, 4 coins. Okay. So I'm going to say transact. Transaction has gone through. Now, if I check the 10th account's balance, you can see it's 1, 2, 3, 4, right? If I check my balance, which is the first account's balance, you can see that it is 1 million minus 1, 2, 3, 4, 998,766, right? That's it. We just created a Bitcoin like coin or token. It was that easy. Okay, few minutes. Now we will move on quickly. These tokens, these coins that we just created, they are called fungible tokens. Okay, so I'm just going to stop sharing and we'll take 5 minutes to understand this concept. Okay, so these tokens that we just saw, they are called fungible tokens. What does it mean by fungible? So let's say you have a 100 rupee note in your pocket and I have a 100 rupee note in your pocket. So if you give me your note and I give you my note, is it going to make any difference in terms of value? No, right? It's like the same thing. You have 100, I have 100. So your 100 is equal to my 100, right? So any other 100 is equal to any other 100. Any other Indian rupee is equal to any other Indian rupee. Every US dollar is equal to every other US dollar. Every Bitcoin is equal to every other Bitcoin. Every Ether is equal to every other Ether, right? And it doesn't matter how many you have. Okay. For example, if you have 1 gram of 99 karat gold and I have 1 gram of 99 karat gold, we can exchange that without having any issues, right? So when you can exchange an asset with another asset without any change in the value that you are holding, then it is said that you have a fungible token. Okay, so all the coins, all the blockchain coins, created using ERC20 or native to a blockchain like Bitcoin, Dogecoin, Litecoin, etc., or XRP, they are all fungible tokens. They are fungible coins. Okay, actually I'm using the terms coins and tokens a little interchangeably to give you a quick understanding. If a coin or let's say cryptocurrency, if a cryptocurrency is powering a blockchain network, like Bitcoin powers Bitcoin network, or Ether powers Ethereum network, or Litecoin powers Litecoin network, or XRP powers XRP network, right? If we are doing that, or AVAX, right? AVAX powers Avalanche network. Binance Coin powers Binance Smart Chain, right? So these are the native coins. These are used in the mining. These are used to enable consensus and security of the security of the underlying network. So these cryptocurrencies are called coins. Okay, these are coins. If you create a cryptocurrency on top of another blockchain like Ethereum by writing an app, by writing a smart contract, so it is not living at the networks level, at the blockchain level. It is living at the applications level. It is living at the smart contract level. When you create a cryptocurrency like that, then it's called a token. So there are two kinds of cryptocurrencies. Okay, a coin and a token. You can follow me on LinkedIn and go through all my posts. I've explained all of this there. Okay, it's like there's no point going into these little details, but these nuances help you understand what's going on. Anyways, so we are basically creating tokens here on top of Ethereum network. Okay, using a 10-line program called ERC20. All of these tokens are fungible. Every VIT coin is equal to every other VIT coin. Now, a question was raised, and it was this, right? Why do we need to have fungible coins? Why can't we create fungible tokens? Why can't we create a token which is not equal to any other token? It is unique, it is there. Okay, and it's the only token that we have of that nature. There is no other token. Now, what could be the use cases or applications of this kind of a program or this kind of a smart contract, right? So we could have, I could like create a painting, right? And I could tokenize it, and then I could sell it online. One, I could tokenize my house, I could tokenize real estate, or I could tokenize a piece of land, right? In my startup, we were tokenizing packets of food items. Okay, so we were tokenizing a packet of methi or a punnet of grape, and then we were tracing them through the supply chain using blockchain. That is what our startup was doing. Okay, so you can basically you can convert your identity into a token. So my identity as a token is not equal to anyone else's identity, right? I'm unique among 7 billion humans. So when you create a token that is not equal to any other token, at that time it's called a non-fungible token, because it's not fungible. Non-fungible token equals NFT, and this is what we have right now as the big hype. uh, I agree with Vitalik that just having some images of apes or some like our digital art being tokenized and buying and selling that is not the real use case of NFTs. Okay, but it's just one of the use cases, and it is finding traction. So my point is, you can tokenize, you can create an NFT out of digital art. That is one use case, but there are 100 other use cases of NFTs. So don't confuse an NFT with digital art or digital collectibles, like we call. Like if you are into gaming, you like if you play Dungeons and Dragons, right? You have these collectible cards and all that. In childhood, we used to do that, right? So it is just like that, but digital collectible cards. Okay. So what standard do we need? So if we want to create a non-fungible token, what standard do we need to use to like create that token, right? That's a big question. So there is this standard which is developed and almost everyone uses it. It's called ERC 721. So it's 721. Okay, now I'm going to quickly go and show you how to create this token and show you how it connects to the image, right? Because blockchain smart contract cannot store image, it will be very expensive to do that. Like your gas cost will kill your application. Okay, so you what you have to do is you have to create your smart contract, and then you have to give a URL, a link. Okay, a link to the image or link to the NFT's metadata. Okay, metadata means the NFT's name, the NFT's description, NFT's whatever that you want to see, right? The image, right? So you just store that URL which points to that metadata in the contract. You don't store anything else. Okay, but the contract itself will ensure that there is only a unique token of that token ID existing. Okay, so let's go back to Remix. Now, in fungible tokens, we did not have a concept called token ID. Okay, so this just 1 second, I'm going to zoom out. Okay, so we have this. Now we want to create another contract, and let's call it VIT Fun NFT dot soul. Okay, I'm gonna copy the identifier quickly. I'm gonna say contract VIT Fun Soul. Okay, I will zoom it in. Don't worry. Now we need to import ERC 721 from OpenZaply, right? So this is the 721 standard. And also, if you want to make a career as an engineer, get into the habit of reading documentation. So if you want to learn OpenZappelin, it's always better to go to OpenZappelin site and read all this stuff and try it out. Okay, don't rely on, like, there are good YouTube courses, but not all of them are good. So you have to search for a lot, so just keep that in mind. Get into the habit of reading documentation. Okay, so what is this? Why is this saying ERC 721 storage? Yeah, we're gonna keep it simple. So we're gonna say just import the 721. Now inherit 721, just like we did. Our contract constructor has no input, but ERC 721 will have some input. So we need the name and symbol. Again, same thing what we did in. So we have fun VIT NFT is a name, and we're gonna say VIT NFT as the symbol. All right, and that's it. In fact, I think we are done, unless, okay, but we also need to set the base URI. Just 1 second. Give me a second. I actually don't work with 721s. I work with other standards. So I'm just going to take a moment here. Okay. So the next thing that we need to do, everybody can see my screen, right? Just gonna pull this here. Okay. So we have the constructor. We don't need anything else here. Now we want to say that there's a base URI. So that, where is your image stored, right? Where is your metadata stored? So you want to point your token to a particular URL, right? So that your wallet or any other software can load that. Okay. So what you're going to do is you're going to say function base URI, right? This is a function inside ERC21, so we are just overwriting it. We are not doing anything else. We just want to set our own thing, right? We're gonna say string, so this returns a string. You can just copy paste all of this stuff, no worries. The important thing to understand is you have to return the URL, right? So let's say https://vit. So we say, let's say nft.vit.com, right? This is the base URL, and then a trailing slash, right? Then we want to mint NFTs, right? So we want to have a mint function. Okay. We are minting to one address, like let's say address 2, and we are minting a specific token ID. Okay. All right. We're going to say public, and there's a special function inside 721 called safe mint that you have to use, and you just say to token ID, and done. We're done with our ERC and NFT ERC 721 contract. I'm going to zoom this in. Okay, we'll go to deployment. We are still connected to Ganache, which is a good thing. I'm going to get rid of this contract. I'm going to deploy VIT Fund Soul, right? So I just deployed it. And you can see we have all the functions required for an NFT in ERC 721 standard. It is slightly different than the ERC 21. Let's see how. Okay. So we want to see balance of address owner. So let's just get the read functions out of the way. So if I say symbol, it's VIT NFT. Okay. If I say name, fun VIT NFT, that is good. Okay. Now here we are saying that there's only one token of one kind. That means every token needs to have an ID. So we will have token ID like 1, 2, 3, 4 or 9999, doesn't matter. But if I mint a token of token ID 9999, there's only going to be ever one token of token ID 9999. We cannot mint it again. Okay. That is why it is an NFT, and that is how we implement the non-fungible characteristic. Okay. So let's try minting one. Okay. So we are going to say that, let's say mint to the ninth address, right? From the first address. So I'm just going to say ninth address, right? And token ID 123. Okay. And that, did it go through? Yeah, it has gone through. That means now if I go and I check balance of this address, it should show me one, right? This address has one NFT, right? But we also want to see who is the owner of 123, right? So if we say owner of 123, we can see that it has this address 6238. Okay. Then the most important, now I can transfer, now this address can transfer this NFT to another address also. I'm not going to get into that detail, but let's say we try to mint 123 again. Okay. So let's open console so that we see the error. And I try to mint 123 again. You see there is an error. It's saying ERC 721 token already minted, right? So it's saying this token has already been minted. Now you can play around with this. You can transfer from here to there. You can see what this approval function does and play around with it. But the most important part is, how is this token pointing to the image or the metadata URL, right? So there is a special function called token URI. If you pass the token ID to it, it's 123, see what it is returning. It is returning https nft.vit.com/123. All right. So what it is doing is, it is pointing to this URL. This token is pointing to this URL. And if you, at this URL, if you store the metadata in a special format, I'll show you how. Then it will load your NFT into, if the app can show it. All right. So the question is, should we store this image and metadata on nftvit.com? No, right? What if your server goes down? What if VIT server goes down? Right? Then people cannot see that image. So they will just have a digital record saying my address is token ID 123 NFT 123, but I don't have, like, I don't have the image for it, which is what I paid for. So in order to ensure that the metadata and images are always persisted, we use another distributed network. That network is called IPFS, Interplanetary File System. Okay. It is just like a blockchain network. It's a distributed, decentralized system, just like blockchain, but it doesn't have smart contract. It just does plain dumb file storage for you and nothing else. Okay. So what we are going to do is, I have already actually uploaded some of the things on IPFS. If you want to upload stuff on IPFS, you can go to this site called Pinata. So you have to open a free account on Pinata. See, my account is already here. Did they unpin my files? I don't know. Let's try this out. So I have already uploaded this metadata file. Okay. Let's see if I can access. Yes, I can access this. Okay. So you can see I have already set up this base URI, okay, on IPFS, and it has token ID 101. Okay. And it has three things. It has a name, a description, and an image. If I take the image URL and I post it here, you see, so this is Jon Snow's image. Now I'm a big fantasy buff, so I've created Game of Thrones NFTs. Uh, we have another image here. You can try it out. So the thing to understand here is the token ID from smart contract using token URI function points to the metadata URL. So this is metadata URL, which is JSON. You should know about JSON, at least third year final year students, because without JSON you cannot work, cannot be an engineer. So study JSON if you haven't. It's a human readable format of representing data, right? And I'm getting some pings. Second. Yeah. All right. No worries. Okay. So the point to understand here is that the token URI function points to the metadata URI. You get the metadata URI, and inside metadata URI you have bunch of stuff. So you can write an essay here. Okay. It doesn't matter what you write. People write terms and conditions, etc. They do whatever they can do. Okay. The most important part is this metadata URI points to the image URI, which is this one. And if I load the image URI, it's here. Now the magic of IPFS is once you pin a file, it is always there. Like you don't have to maintain a server, you don't have to do anything. Anywhere you go in the world, you will be able to access this file. That's why we use IPFS. But nothing stops you from like hosting this metadata URI or image URI on your Google Drive, for example. You can do that as well and point your contract to your Google Drive URL. So it doesn't matter. Okay. Now what we need to do is we need to properly construct our base URI, right? So my base URI right here is this, right? So you can see it's some gibberish, right? And after that token ID. So I'm just going to pick up that gibberish and I'm going to say is my URI. Now I need to delete this because this is still the old contract instance. I want to deploy the new contract instance. I go here, and if I say 101 now, what is happening? Do I need to mint 101 first? Okay, let's try minting 101 first. I'm going to mint it to myself. 101 mint. Always keep an eye on console. Yeah, it's gone through. Now if I do 101, yeah, you can see that I have generated this URL. And if I just copy paste this in the browser, it should point me to metadata, and from metadata it should point me here, right? Now how do we see this NFT in the wallet or in the in some NFT marketplace? So we have certain NFT marketplaces where people are already doing this as a business. So biggest marketplace is OpenSea, right? So you go to OpenSea, the largest NFT marketplace, and you click on explore, and you can see that there's a lot of NFTs here. Okay. I want to give some time to question and answer. Don't want to do a monologue. So I'll just show you how to connect to. So I'm just connecting. So if I just click on MetaMask, I just told you that you don't have username password in. So this is a dApp. You don't have username password in dApp. So you just have connect wallet and disconnect wallet. They will ask you to sign terms and conditions again using the wallet, right? And I need to deploy my NFT on the actual Ethereum network, which I'm not going to do obviously because it will cost us money. But you can follow exactly the same process on a testnet, okay? And you can deploy your contract on testnet, okay? And then you can play around with it. I am going to keep these things for you. Otherwise, if I show you everything, and we are out of time as well, where's the intellectual stimulation, right? You guys will not try anything when you go home. But the major reason is we are out of time. Okay. uh, I'll show you one more thing, which is how to connect. So right now we connected a remix to Ganache. How do we connect a remix to MetaMask? Okay. So here in the environment, instead of choosing Ganache provider, which is your localhost environment, you are going to choose injected Web3. I'm going to say next. I say connect. Now you can see that my account has been connected. Now this is my, just 1 second, you can expand MetaMask, pin this. Computer is a little slow, I have like 100 things running. Okay, expand queue. So this was your MetaMask wallet. You can see your account has been now connected to Remix. Okay, you can see it is connected to some gibberish random network. The reason is we are currently selected localhost 85545. If we, let's say, select RinkB testnet, RinkB is like RinkB is like Ethereum, but it's a test network, right? So you can get free dummy ETH to work on RinkB. All right. So once you do that, we need some dummy ETH in RinkB, right, to play around with it. So where do we get it? So there's a great site called faucets.chain.link, which is hosted by Chainlink platform. Okay, I can just connect my wallet. So you can see it automatically detects I am on RinkB network, and I can just say, okay, send me 0.1 test ETH to my address, right? I'm human. Oh my God. Okay, what is this? Each image containing a boat. Yeah, I'm not a bot, hopefully. Okay, send request. So now we just sent a transaction to RinkB Ethereum testnet telling us that give us 0.1 test ETH for test. So the request is complete. Close. I go here and you can see we have 0.1 RinkB ETH. So this is fake ETH. Don't try to sell it to anybody. This is just for testing. Okay. And now here we go. You can see that when I selected injected Web3, before it was some gibberish network because we are connected to Ganache. Now we are connected to RinkB network, and each network has a ID. So RinkB has ID 4. The main Ethereum network has ID 1, right? So this ID is very important. You need to know which network you are connected to. And now you can see we have 0.1 Ether. Now let's say we want to deploy our NFT contract on, so we have this VIT fun NFT contract, and we want to deploy this on RinkB. Okay. So we are going to select our contract. Okay. And I'm going to say deploy, see what happens. It launched MetaMask. What Remix is doing is Remix is saying, okay, deploy the transaction through this account via MetaMask. Okay. And you can see MetaMask is asking me, okay, you will need this much Ether to deploy this contract. So I'm going to spend this much Ether. Just going to say confirm. I can go to MetaMask and check my activity. Contract deployment is still pending, and you can see my contract deployment is done. Okay. Now, where do I get the contract address from? Okay. I can just click on this transaction. I can go to view on block explorer. This is the blockchain explorer, right? So you can see this is my transaction. It is a contract creation transaction, and we are right now on RinkB test network. So this is the blockchain explorer. Here you can see everything. Okay. I can show you how stuff looks like here. So you can see my address has already done a few transactions. The first transaction was I got 0.1 Ether, and the second transaction is I'm trying to create a contract. You can see our contract is created. If I just open this, so I have created ERC 721 contract. Okay. Did I deploy 721 or 20? I'm not sure. But anyways, you can go to contract. You can do a bunch of stuff here. You can decompile bytecode. You can verify the contract, and then you can directly interact with it from the blockchain explorer. Now, if we can mint and send tokens to each other. Okay. So I want to try this. Does anybody have a blockchain address? Did anybody install MetaMask? If not, it's okay. I could have sent some things to you, right? So I'm just gonna run Ganache to get a dummy account. So this is a dummy account. I'm gonna transfer. Okay. what I want to do is I want to mint one NFT to do not use these addresses because their private keys are public. They are being streamed right now, so don't send actual money to them ever. 123. As soon as I transact, I'm minting to this address 123. Again, it will go through MetaMask. Why? Because we are sending the actual transaction to a testnet. So you, for local testing, you did not need it because you had your local Ganache running. But here, so it will cost me this much ether. I can go back to MetaMask. I can see this is a mint transaction. It's pending right now. I go here. I can view on Block Explorer. We can see that this transaction has been completed. Okay. All right. This transaction is completed from my address to this address. We can go to Remix now and we can check the balance. Okay. So balance of this address is one. It takes slightly more time, you must have noticed, because we are actually interacting with the actual network. Even though it's a test net, it is an actual network of computers. It's like a mini Ethereum or a baby Ethereum, right? And then you can just go owner of, and you can check if the owner of token ID 123, was it 123? Yes. Is this guy? Yes. All right. And token URI for 123 is this, but there's no data on 123 right now. So I will share this address with you, which is already deployed on Ringb, and you can go ahead and you can upload, not upload, you can mint your own token. So I already have 3 metadata URIs. I will share that information as well. So this is Jon Snow, this is Tyrion, this is Daenerys, and you can mint a number of NFTs. The contract is not restricted. Once you mint your NFTs, you have to go to OpenSea and connect this contract, Ringp contract, to OpenSea, or you can connect it on MetaMask mobile as well. You can install a MetaMask mobile app and you can send the NFTs to yourself, and then you will be able to see the images. I will leave that as a challenge because we are out of time. Please let me know through the organizing committee how you found this and were you able to actually see some NFTs. We actually need more time to go through that, but or do you want me to show that, Medash? Let's do one thing. After Q&A, if we have some time, then I can show you how to load the NFT on your mobile. All right. So yeah, I'm done, Medash. Hello. Medash, you can start Q&A. I'm more focused on that because I want to understand what the audience understood and what kind of questions they have. That should be more fun rather than me talking. Yes, please start with Q&A.
So,
Okay, Medansh is. Hey, Medansh. Yeah.
so we can start with Q&A right now.
Yeah, because that showing the NFT on the mobile is going to take a lot of time, Medansh, and I don't want to waste
We'll do it
time.
later on. We'll do it after the Q&A.
Yeah.
Does a low block time means less amount of data in each block?
It's a very, very good question. When you have a low, it doesn't mean that, because let's say your network, your blockchain network is being used by hundreds of millions of people, and hundreds of millions of transactions are coming in every second. So it is not necessary that block time is related to amount of data. There is another parameter called block size, or it's called a block gas limit in Ethereum, which defines how much data your block can hold. So block time is more related to consensus, and block size is more related to how much data you can pack into a block. I hope that answers the question. Kaustubh?
So, what platforms are famous for developing blockchain applications?
Very good question. Okay. So I just showed you Ethereum. If you want to develop on Ethereum, you can. So there are two kinds of chains. Okay. There are chains which are compatible with Solidity and EVM. So basically, you can write Solidity smart contracts on all of these chains. Okay. So these chains are Ethereum 1, Binance Smart Chain 2, Avalanche 3, Hedera 4, and Polygon definitely. But Polygon is not a network in itself. It's a network, but it's a child of Ethereum, you can say. It's a layer 2. So Ethereum is the parent and Polygon is a child. But you can also write Solidity programs on Polygon. Polygon is actually developed by Indian founders, and it's one of the biggest blockchain networks in the world. So we should be proud of that. There's other networks which are not EVM compatible. That means you cannot write Solidity smart contracts there. So the biggest, so other ecosystem is Rust. Rust is a programming language, and Solana blockchain and Polkadot blockchain use Rust for writing smart contracts. Rust is difficult. I'm still like in the process of studying it. So you can go for it as well if you think you are a good systems programmer. But I would suggest start with Solidity, and then once you are good with Solidity, move on to Rust-based chains.
What happens if the execution of a smart contract costs more than the specified gas?
So your all your gas will be consumed, and your execution is still not completed, your transaction execution. So your all your changes to the state will be reverted, and all your gas will be gone. So you will lose money without actually doing anything.
Do you think the concept of ever changing gas price is wrong? Something being so fluctuating can make one user pay much more for the same work.
That is true. Okay. But for this, okay, I did not get into this is a good question. I did not get into difference between gas and ether. Okay. When we say gas, gas actually shows you the amount of computation required. So let's say you do a addition operation, x plus y in a smart contract. So it is always going to have same gas units. Okay. Always same, because that is defined by EVM. But you need to pay for gas according to what is the gas's price. Let's say it costs you 200 gas to do addition operation. So what is the network's gas price currently? The reason it is ever changing is that you need to incentivize the miners. So if you give more gas, let's say the network is more congested, like more people are trying to send more transactions, right? So how do you decide whose transaction to include in the block and whose transaction not to include in the block? And that is miner's job, right? So miner will include your transaction if you give more gas price, because they are going to get fees out of that, right? So it's like standing at a petrol pump station in a line, but if you are ready to pay for more petrol price, if you're going to pay a higher price, then you will be bumped up the queue, right? That's the analogy I use explaining what is gas price and what is this. But you need that, you absolutely need that. Imagine we directly measure addition operation in gas, and everybody is going to pay the same price, right? And hundreds of thousands of people are sending the same transaction, addition transaction. but you cannot include hundreds of thousands of transactions in the same block. So whose transaction do you include, right? So there has to be some stake, otherwise I will keep flooding the network, right? So there has to be some stake, and that stake is in terms of money.
What are off-chain transactions and on-chain transactions?
There's nothing called off-chain transaction. There are off-chain actions. There are some actions that you can do outside a smart contract, right? And there are some things that you are doing in the smart contract. Whenever you do something in the smart contract, it's an on-chain transaction. Off-chain activities are required. For example, let's say you want to create a betting app for IPL or World Cup, right? So you need to, like, you write all the logic odds, like a better puts in money, bookie puts in money. I should not say all of this, but this is just a fun app that I worked on some time ago. So the problem here is that you need to know who won the match, right? India versus Australia, who won the match. So smart contract does not know about it. It is just going to take the input that, okay, India won the match, and pay off this much money to the two maker and taker, the player, right? So where does this data come from? So this data comes from outside the blockchain, and this is called an off-chain data. Okay. How do we get trusted off-chain data? You need something called an oracle for that. So whenever a smart contract wants to interact with the external world, you need to integrate the smart contract with an oracle. There is a company called Chainlink that provides you external data feeds into the smart contract. So that's an advanced topic, but you can check it out on Google.
Do you think the proof of work was more inclusive, as one cannot participate in proof of stake unless he holds the significant Ethereum?
Looks like Shrisha has already done a lot of research. The algorithm that I showed you, right, finding a special number, repeated hashing, is called proof of work. Proof of stake is a different algorithm, but the goal is the same, is to ensure that all nodes arrive at the same answer and all nodes look at the same blockchain. Okay. In proof of stake, I have to put up some money. I have to put up some ETH coins in order to become a miner. Okay. There, you don't call it a miner, you call it a validator. In now, if you're asking my personal opinion, it depends. You're right. If one person has a lot of ETH, then they will be able to control the network, but that doesn't happen in practice. Okay. That is why we need to see the network is sufficiently decentralized or not. If it's a proof of stake, then we need to see how many players are there, how many addresses are staking how much, and we need to analyze the addresses. It could be that I am the one person, I have billions of ETH, and I have like 1000 addresses, and I'm staking all of that, right? So it could be all controlled by one entity. So you have to analyze that. So there's no yes or no answer to it. It's not black and white. You have to analyze the consensus mechanism and the distribution of stake.
Can I sell my existing NFT on my own website?
Yes, definitely. But then you will have to create a website that interacts with your smart contract, right? So this is a DApp. So when we say a DApp, decentralized application, it has. Hey, sorry for that. I was saving on bandwidth. Okay. So when you want to, sorry. So if you want to sell your own NFT, you have to create a website which talks with your ERC 721 contract, right? How do you do that? How do you integrate? So you first have to create a UI using some UI technology. Now there is no blockchain here. You can use React, you can use Angular, you can use plain HTML, JavaScript, but you have to integrate MetaMask with it, like how to connect the wallet. Just we saw that, right? Some websites were connecting to MetaMask. You have to do that, and then you have to send your transfer transaction to the blockchain smart contract. So this is a full dApp development. You can go to Patrick Collins's course to understand how dApp development is done, but you need to know JavaScript and UI development for that. So if you guys haven't started it, I would suggest like learn React. React is the thing right now in the market. So learn React and directly connect it with smart contract. That's it. Dap.
Is it profitable to mint NFTs and sell it on OpenSea?
That's more than engineering. That's a creator question. So if you are good at digital art, let's say Pritesh, you want to like mint something, so create your own digital art, amazing painting or something like that. and then you can list it on NFT. So what NFT does is listed on OpenSea. What OpenSea does is it provides you NFT as a service. So what does it mean is you don't need to worry about this smart contract and like dApp development and all of that. You're a creator, right? You're a digital artist. You don't need to know about engineering. So you go on OpenSea, you connect your wallet, and then you upload your image, and then you mint an NFT. So it will do all of it for you, and then you can list it for sale, right? So you can just sell it for some in exchange for some ether. The thing to understand is this selling and buying that does not go through the contract. It is at OpenSea's level. It is OpenSea's app that is doing buying and selling for you. It's not the contract that is doing buying and selling for you. Contract can only do transfer and mint. That's it.
How secure is ERC 721 NFT?
If you now that depends on your coding, right? But if you use the vanilla OpenZeppelin 721 implementation, it is pretty secure. uh, because it is already audited. It depends on your mint function, right? So the mint contract that we deployed, deliberately kept it so that there's no access controls on it, right? That means that anybody can call the mint function. So Akshit, you can also call that mint function on Ringbe testnet and mint NFTs to yourself or anybody else. If you want to restrict that, then you have another contract in OpenZeppelin called access control. So you should go through the access control section, and you can see that you can say that only this address can call this function. So only the owner, the person who deployed the account which deployed the contract, can call the mint function. So you can restrict it like that. I deliberately did not do that, but again, the vanilla implementation of 721 is very secure, but what you do with it is also important.
How do you ensure that a physical asset and associated NFT remains connected?
Physical asset and NFT, that is where the Oracle problem comes in, right? So in our startup, we were creating, let's say, NFT for a 500 grams of grapes, punnet, right? And we tokenize that. So how do you do that? So we need to get data feed from some other system which tells us that okay, punnet of grapes for half kg has been manufactured. So we had to actually integrate with the ERP systems of our clients, and those ERP, the factory systems, you can say factory manufacturing systems, and those systems were acting as oracles to our smart contract. That is how we did it. So you have to trust the oracle. You cannot, like, let's say it gives you the false information, then you will mint a false NFT. So you will mint an NFT, but there is no physical asset in the real world. The best way of doing that is putting a barcode or a QR code on it, so that you can always, and then there are some techniques to ensure that QR code is not duplicated. But yeah, you have to put thought into it. It's a more complex architecture.
Do artists have any sort of copyright over the stolen art that has been converted to NFT?
Wow, that's a very complex question. I'm not a legal expert. Uh, yeah, if I steal someone's art and I convert it into NFT and someone is ready to buy it, I don't see how copyright comes into the picture. The problem with this is that blockchain is not regulated. Nobody can regulate it, right? Governments are trying to regulate it, but once the contract is there and once I create an NFT out of someone else's art, um, if there is a copyright on that image, for example, I did the Jon Snow image, I'm pretty sure there is a copyright attached with it. So if I put this on the main net and I try to sell it for actual money, then it would be definitely a problem for whoever who created that image in the first place. So they can sue me, they can take me to court, but they have to do that actively. It's not a automated mechanism. But again, I'm not a legal expert, so I really cannot answer that question.
Does sleep minting on NFT pose a security threat?
What is sleep minting? I don't know. I'm sorry. Like I said, I'm more of a financial applications person. So we use NFTs, but we use it for this. So I'll get back to you on that. I'll Thanks for letting me know. I'll check it out. Sleep netting.
If the digital file in IPFS is deleted or the IPFS provider goes offline, How can we ensure the persistence of NFTs?
That's a brilliant question. Okay, how IPFS works is that let's say you want to, so if you want to persist an image on IPFS, IPFS is a network of nodes, just like blockchain. So if I run my own node and I upload my image there, okay, and then I have to do a process called pinning. So if I pin that image to my node, then it is always available as long as my node is up. Okay, if my node goes down and my image is only pinned to my node and not to any other node, right, then that image won't be available anymore. So in order to solve this problem, there are certain third party services like Pinata that I showed you. There's Infura service also, IPFS service. So what it does is it ensures that there is like a bunch of IPFS nodes which are always up, and I can just upload my image and pin my image to their nodes, okay, in exchange for a small fee. And it is their job to ensure that at least one node is always up and running, so that always my image is available all over the world. So, but you have to pay for that.
Is there any possible way to trace the location slash IP with wallet address and transaction details?
Amazing question again. You have to. Now it depends on the wallet software. I honestly don't know if MetaMask tracks our IP address. I think it does, because there was some issue with Venezuelan clients. Like there were some users in Venezuela and I think in Russia also. And due to the war, consensus has banned them from banned those addresses. Right. So how did they do that? Because they knew where the MetaMask was installed and where it was getting the transactions from. So I think MetaMask tracks it, but I'm really not sure about it. So the best way to do would be to not use a wallet software and do everything yourself. But then you have to store all the private keys. You have to do all the stuff on your own computer, and you have to keep your computer safe and air gapped. So another way to do this is you can use hardware wallets. So these are like USB stick kind of devices, like pen drive kind of devices, which have special like blockchain chips, which do all the cryptographic algorithms for you. So you can put that into your laptop and it will act as a wallet. So these are called hardware wallets. They're pretty expensive, by the way. Any other questions?
So that's enough. Thank you for your time. It's been an amazing session. We learned a lot, and like this session was really amazing.
Yeah, I tried my best. I generally like to take time and like slowly walk you through in a fun way, but we did not have enough time for this. So I like hard fast track some of the things. But I would suggest if you are interested in blockchain technology, please check out the resources. Patrick Collins course, Open Zeppelin library. Try to create your own NFT. Try to view it on your MetaMask mobile or on OpenSea and try it out. It's a totally different technology than AIML. Some of the people ask me like, is AIML and blockchain related? In my opinion, they're not at all. Like even the math required in blockchain and math required in AIML is completely different. You need to know cryptography in blockchain. So if you want to make your career in blockchain or Web3 or dApps or smart contracts, so you have to get into it. One. Second, you need to know one of the two languages. You either need to know Python or you need to know JavaScript. I prefer JavaScript because you can do front end and back end and everything in JavaScript. So I'm JavaScript everywhere, a proponent of JavaScript everywhere philosophy. So Node.js, React.js, if you haven't studied and if you're interested in JavaScript, go for that. If you're interested in Python, go for Django and how to like web3.py library, which helps you interact with smart contracts. Sorry, Medash, one more point I missed. So when you want to talk with a smart contract, you need a library. Okay. So that library could be a Python library or it could be a JavaScript library. So in JavaScript, we have two libraries called Web3.js and Ethers.js. And in Python, we have a library called Web3.py. Okay, so it's up to you which one you want to go for. Sorry.
That's all for the sir. It was great having you with us.
Yeah. Um, I can help you guys. You can follow me on LinkedIn. I keep posting a lot of stuff about cryptography, zero knowledge proofs, which is an interesting topic, and about blockchain. Definitely, you can follow me there. You can also ask me questions regarding anything related to JavaScript, full stack development. You can ask me questions about cloud and DevOps, and definitely blockchain and all of this stuff. So, yeah, that's me. One second, Mitash. Uh, yeah, I think all the questions have been covered, right? There are no more questions. We can take 5 more minutes if anybody has a pressing question.
No, so there are no more
What is the
questions.
gas
Yes,
price
yes.
keep varying? I think I answered this. So basically, according to how much a network is congested, like how much people are hitting it, how much load it has. So if there are a lot of transactions coming, then you need to decide which transactions to include in the block, which transaction is not. So let's say nobody is using the Ethereum blockchain. It's all lightweight and very few transactions are coming in from users. Then you only have to pay the base fee, right? You don't have to pay any fee on top of that. Okay, but a lot of people are using it. Then how do miners decide which transactions to include? So you will have to pay more price for that. Flash
Any
loan
suggestion on Flash?
resources. Okay, you're getting into DeFi. Okay, all right. You can study Aave and how the flash loans work there. So flash loan is a loan where you have to pay it back in the same block. So within 13 seconds, basically. So you can go ahead with, why do you want to create a bot, Govinda, to hack someone? Why do you want to go into flash loan? But DeFi is an entirely new thing. So you need to understand how lending protocols work. You need to understand how Uniswap works, like Dexis. You need to understand how stable coins work, staking works. So that's a whole new session. It would take me like 4 hours to explain all of that. So if you guys are okay for it, Medash, maybe you can check with your professors and like arrange a session for financial DeFi applications.
So we'll talk about that class. Yes, we'll
Yeah.
surely talk about it. So today we really learned that NFT is not just digital art and way more than that. It was really amazing having you. And
Yeah.